All right, everyone is ready? Everyone is ready with your idle?
Yes, sir.
Okay. All right. So I hope all of you practiced some of the Python we have been doing. Okay. So there is. I would like to.
Yes, sir.
I would like to re-emphasize that there is no substitute to coding, practicing Python. Okay. I'm here to guide you, provide you all the materials, and do these things along with you. But finally, the learning has to happen with each of you, isn't it? And there is no substitute to practice. Practice is the only way to learn programming, and that is why I also adopt the same sort of a teaching approach to Python. Okay, that is having a live, practice sessions, hands-on sessions, isn't it? All right. So I hope that you are practicing Python. Okay. So let's continue from where we left off yesterday. I hope all of you can see my screen. So let's go into sets today. Okay, if anyone has any doubts with yesterday's session?
Sir,
there was a
but just one small. I just wanted to know a small difference, sir.
Yeah.
I'll paste that in this chat box.
Okay, you paste it in the chat box. We'll proceed with the class and we'll come to the doubt when we have a break. Okay. So go ahead and put it in the chat box. Alright, so anyone has doubt, just put it in the chat box. You can also open a question and answer session. Maybe we can do that. Let me see if I can open a question and answer session. Yeah, people in the meeting can post questions. So Vijay, you just posted in the question Q&A session. I'm just opening that up. Hopefully it will be visible to everyone. Yeah. Okay, so it's starting. That's fine. All right, so let's get into sets. Okay. So yesterday we saw dictionaries, and we saw that dictionaries are made up of key value pairs, and they are very interesting sort of data structure. And because of their uniqueness, they come in handy in many different situations. All right. So the key has to be unique in a dictionary. You can't have the same key for more than one item. So every item has to have the unique key, and the key is mapped with a value. And the value can be any data type, but the key has to be a string, number, or a tuple. Okay, so there's a constraint only on the key. Okay, and you can create a dictionary simply by using the angular braces and separating the key and the value by using a colon. Okay, and you can iterate over a dictionary by using dictionary.keys or .values or .items. And there are many other methods with dictionaries because they are mutable. Okay, and we saw some of the methods yesterday. Some of the essential methods. Today we'll look at a new data structure, and this is the last data structure, inbuilt data structure that we will be seeing in Python. Okay, so we have seen list so far, we have seen tuple, and then we have seen the strings, and then we have seen the dictionaries. These pretty much cover all the data types we would want to use, isn't it? Okay, so there's one more data type, and we'll see what motivates this data type. That is the last inbuilt data type that Python offers us. With this, we'll be covering all the inbuilt data types that are there in Python. Okay. So this last data type is called as a set, and you may be familiar with a set from mathematics, from your school maybe. Okay, and some of you have even done a BSc, bachelor's in mathematics, the data science students. So I'm sure you've done a lot of set theory. Okay, but even those in computer science would have done some sets in discrete mathematics maybe. Okay, so anyway, so we're all familiar with sets, okay, and we also have a common day understanding of what a set means. Okay, so here the notion of a set is, is pretty much carried forward in Python. And so what are its properties? Basically, a set in Python, it is unordered. Okay, a set is unordered because it is just a collection of elements. So there is no index or anything. It's just a collection of elements. So there is no index. It is not ordered. Okay, so this is a key difference between from the other data structures. Okay, so it is unordered, just like a dictionary, but you can iterate over a set, but you won't know the order in which the iteration happens. So it's a risky proposition. And then a set is mutable, and it can contain multiple data types. Okay, so these are the properties. And there is one additional property that is specific to a set, and which is that a set is made of unique elements. Okay, so this uniqueness we already saw in dictionaries. That is the keys of a dictionary. I just mentioned has to be unique. So you see the same uniqueness that appears in sets as well. Okay, so in dictionary only the key has to be unique, but in set the elements have to be unique. A set is only made up of elements, isn't it? They are not keys and values or anything. They're just elements like you have a list, tuple or a string. A string is a sequence of characters, a string is a separate data structure. But like you have in a list or a tuple, the set also has elements. But in a list or a tuple, the element can be repeated. In fact, we worked with examples where we use the count method on a tuple or a list to find the number of times a particular element occurs in a list or a tuple. But you see in a set they all occur exactly once. Okay, so the count method is like useless unless suppose you want to find out whether an element exists or not. Then the count will be 0. Otherwise the count will be 1. Okay, so the set is made up of unique elements. Okay, so every element can occur only once. There cannot be any repetition. So you can take a list and convert it into a set, except that any element that is repeated will be represented only once in the set. Okay, so in that way you can easily create a set. So you can easily also remove duplicates from a list. Okay, you may have a very long list. You don't know where the duplicates are. You just say set of the list, and now you have every element appearing exactly once. Okay, this is a very nice way to use a set. A very nice use for a set. Okay, so a set is made up of unique elements. So therefore, these unique elements must be immutable, isn't it? So they can only be strings, numbers, or tuples. Okay, so that is why, just like with keys, we have the same constraint. They can be either strings, numbers, or tuples. Similarly, the set elements can be strings, numbers, or tuples only. Okay, the set itself is mutable, but the elements must be immutable. Alright, so how do we create an empty set? We just say set of. Okay, we just say set of keyword, but you see there is no other way to create an empty set. Because when you have the set elements, you have to put them in angular braces. We saw the angular braces also with dictionaries, but we have a key colon value, but here there is no colon. So these are all separate elements, so therefore they are set elements, and we use angular braces for the set as well. Okay, but we don't use, okay, we cannot say some set, isn't it, set 1 is equal to like this. This is wrong. Why is this wrong?
This can also mean it is a dictionary.
Excellent. It doesn't mean, it can also mean there is ambiguity. So Python has stipulated, okay, that this only means it's a dictionary. So if I say type of set 1, okay, it is a dictionary. So this empty braces will only indicate a dictionary. Okay, even though sets will also have the same structure, isn't it? Okay. So if you want to create a set, there's only one way. As opposed to the other data types, there's only one way to create a set. You just say it's a, you just have to say, suppose you say like this, what does that mean? This is a tuple, okay? So this is not going to work. So you have to say set of. You use the set command and say set of, okay? Now this creates an empty set. Now you say type of set 1. And you have class set. Okay, so there's only one way to create a set. You have to say set of. All right. Otherwise, you can also directly create a set by specifying the set elements. You just say set 1 is equal to, isn't it, Earth, our usual favorites, isn't it, Earth, Venus, and Mars. Okay. All right. So now I say type of set 1. So this is dynamic typing, isn't it? Okay. So I can do dynamic typing, and Python will understand this is a set because there is no colon and a value. So these are not treated like items of a dictionary. They are elements of a set. Okay. So this will work. Now suppose I were to say, isn't it? Suppose let's say I say comma, again I repeat the element. Let's say Earth. Let's see what happens. Okay. Now I say print set 1. You see, it has only the 3 elements. Even though I may repeat the element, it is not taken as another element of the set. It only has the non-redundant, non-repetitive elements. Every element is only represented once. Even if you have the element repeated twice, you only see it once. All right. So, okay. So these are some characteristics of the set that we have seen. All right. Relations with sets. Let's create 2 sets. Let's create one set directly, just as we created the planets. Okay, let's say languages equal to Python, R, and Java. Any other languages anyone likes? Any other languages? Anyone? Alright, we have languages Python, R, and Java. Then let's create a set of snakes. Okay, Cobra, Viper, and Python. Okay, Python is also a snake, isn't it? Alright, okay, anyway. Now to create a set from the set command, I have to give the elements within a list. I say set of a list. Okay, and then if any element is repeated in the list, it is represented only once, and now we have a set structure with the elements of the list. Okay, so we can create a set from a list as well, and this is how we create it. Okay, so let's do both of these. So I'm going to say languages is equal to this. Let me also add C here. All right, and let's say set is snakes are equal to this. A different way to populate a set. Okay, all right, now if I say snakes, all right, this is what I have. Alright, now let's say snakes is actually, let me add one more snake here. What is the snake I can add? Anyone, any snake that I can add here?
Sir, rattlesnake.
Okay. Alright, or we can add a crate or something, but anyway, it's fine. Alright, so now if I say snakes, I have, okay, these. Alright, now let's examine this sets. Okay, what are some, usually what we do is we use the len to find the length of the set, okay, and the len function works with sets as well. So the len function works with all compound data types. Okay, it's an inbuilt function. And then we can also use the membership operator and find out whether some element is there in a set or not. Okay, so we'll see the len of snakes, and we have 4, and then we say let's say Python, isn't it? Okay, Python in snakes. What will be the answer?
True.
It will be a boolean. Okay, so this membership operator tests whether the left hand side is there in the right hand side, is the element is there in the sequence, and snakes does contain Python, so this will be true. Okay, that's a question, isn't it? Is it in snakes? Alright, so now let's do some set operations. So this is why we use sets, okay, because we can perform some set operations, and these set operations must be familiar to you from mathematics. So one is we can find the intersection between two sets, then we can find the union between two sets, and then we can find the complement between difference between two sets. Okay, so how do we find the intersection? We just use the and symbol between two sets, and it will find the intersection between two sets and return that intersection as a new set. Okay, it returns a set object. And similarly, you can find the union using the pipe symbol. Okay, so you may recall that this is and, pipe, or and or operators in logic, isn't it? Logical operators. So they have the same meaning. Okay, but here they are not used in conditions. Okay, they are used between sets. Okay, so this is like operator overloading, isn't it? They also have a meaning here. Okay, just like you see the plus operator can be used to concatenate strings or list or tuples, isn't it? Similarly, the AND operator can also be used between sets to find the intersection and return a set as the output. Similarly, the pipe symbol will return the union as the output. Okay, you all know about set union and set intersection. I don't have to go into that. So you take two sets and return the union of the sets as the output. If you take minus, it will give you the difference between the two sets. That is the elements that are there in one set but not in the other set. Alright, so these are the operations. So let's look at these operations on our objects that we have made. So languages and snakes. So we have Python in common. So it says Python, and that is returned as a set. So I can say some intersect set is equal to languages and what is it, snakes. Okay, and now if I print intersect, I'll have, okay, a set that contains only Python. Similarly, I can do a union between languages and snakes. Alright, so now you see Python is represented only once, but we have both the languages and the snakes in the same set. Now I can do a difference between the two, languages minus snakes. I have all those languages that are not snakes, that's Java, C and R, and I can also have snakes that are not languages, and I'll have cobra, viper, and rattlesnake. Alright, so those are the set operations. This is exactly why we need sets, because it lets us perform these set operations. These set operations are not possible with any other data type. Okay, and this is the uniqueness of set. Now, apart from this, as a data type, the set must also have some standard methods. Okay, so these are operators on set, just like the concatenation operator. Now, we also have methods for the set, just like you must have methods to generally work with any data type. Alright, so these methods are, you can add an element to a set by using the add method. Okay, so this is not append or anything, it's just add. Because you see a set is unordered. So if you say append, you're implicitly you're implying that there is the last element and you're appending after the last element. Since there is no last element in the set, it is unordered, you can only add to the set. So therefore the method reflects that. Okay, so we have it as add method. Okay, so this is a nice way to remember. Once you understand the logic, it becomes easier to remember the methods. You don't have to worry that what it is append for list, but add for set, or like that, or update for a dictionary, like that. You have to understand the the logic behind it. Okay, so once we see the logic, it becomes easy to remember. There's nothing to remember, in fact. Okay, so this is append will not work because the set is unordered, so we can only add, and you can add languages to this. And then you can remove an element from a set by using the dot remove method. Okay, and if you remove a non-existing element, it throws the error. Okay, but suppose you don't want a error if the element does not exist. Remove if the element is present, but don't throw an error if the element does not exist. Then you can say discard. So if the element is present, it is removed from the set. Otherwise, no error is given. Okay. Now, if you want to both remove an element as well as return that element, isn't it? That element should be returned to a variable. Then you can use dot pop. If you want to remove all the elements, you can just say clear that particular set. The set object will exist, but there will be no elements. If you want to add more than one element, it is just like dictionary, isn't it? Where we use update method. Okay, the dictionary is also unordered. If you want to add more than one element, more than one key value pair, we use update in the dictionary. Similarly, we can update a set. If you want to add one element, it is add. If you want to add multiple elements, you update, and you give the so many elements as a list. Okay, you give them as a list argument to the update method, and all these elements will be added to the set. Okay, so Go is a emerging language. It is now quite popular as well. And Spark is a language that is used for big data. Okay, so that is the data science, isn't it? So all of you hopefully know will be doing some Spark later in your PG courses. All right. So and Python has the interface to Spark, and therefore you can access you can do some Spark using the Python libraries too. Okay. All right. So we can try these methods as well, and let's say languages dot add. Isn't it, or SQL, isn't it, the database languages, and then if you say languages and okay, you have all these, and then now you can say languages dot remove of C, and then C is removed now, and now again if you say languages dot remove of C, to throw an error, and if this is there in a program, the program will crash because it says key error, isn't it? So these can be referred to as keys because they are all unique, and we know keys are the ones that are unique. So the elements of a set can be referred to as keys, and in fact the elements of a set can be used as the keys for a dictionary, isn't it? That's a very nice use because you can't go wrong. The elements in a set will appear only once, so you can directly use them as keys. Okay, and you can think about that. All right. Now languages dot I don't want an error. Okay, so I just say discard of C, and then let's see what happens. Now it doesn't throw error. There is nothing that has happened. Now let's say if I want to return an element as well, I just say dot pop some random element, and it gives me SQL now. It is popping out SQL, and I can say some x is equal to languages dot pop. Now x will have a new key in it, some key in it from languages, and languages will no longer have SQL. Okay, it has both removed and returned. So now it has only R, Java, and Python because we removed SQL as well as previously we removed the C. All right. So now if I want to add multiple items to this, add both C and SQL back to this, I say languages dot update of, I put both C and SQL, okay, in a list, and then I also add Spark, okay, and maybe we also want to add Julia, isn't it? I don't know how many of you have heard about Julia. It's another language, upcoming language, all right, okay. So now we say languages, and we have all these languages, all right. All right. So suppose I say, I want to clear it all up. I can just say dot clear. You can try all of that. Now suppose I want to, return the elements in a set in a sorted manner. As you know, the elements in a set are unordered, but I want a sorted order for the elements. Okay, and maybe I want to do something with it. But the return data type cannot be a set. Okay, because the sorted order cannot be imposed on a set, because the next time you call a set, it will be in a different order. Okay, you can try it out. But if you want to maintain the order, then the return data type has to be an ordered data type. So therefore Python returns a list. When you sort a set, it will return a list of sorted elements in the set. Okay, so let's say sorted of languages, and you'll see what happens. Okay, and now you see it's sorted in the ascending order. Okay, that is the alphabetical order. It has been sorted and it returns it as a list, and you can assign it to some list variable. All right, and similarly the sorted, as we know, takes many arguments. You can sort it in the reverse alphabetical order. You can also sort it on some arbitrary key, isn't it? Okay, using the key argument. So let's say I want to sort it by the length of the language. So then what I can say is, I can say sorted, and then I can say key is equal to length. I give a function here, and the function is length. And now you see, by length it is sorted. So R, C, isn't it? R comes before C, maybe, or whatever it is. They are both single letter languages. Now SQL 3 letters, Java 4 letters, Spark 5 letters, Julia 5 letters, Python 6 letters. Alright, so now we have the languages sorted by the length of the key, isn't it? So that's wonderful. So we can do some custom sorting as well. Okay. So I'll post a separate tutorial video on this custom sorting. So those of you who wish to further reinforce this custom sorting, which is like a a great feature in Python, okay, which makes it very simple to do custom sorting, isn't it? Okay, it's very, very useful. You'll find applications in many different areas. So I made a separate video on that. I'll provide that video, okay, as a tutorial video. I hope you're all watching the tutorial videos as well. They are all just bite-sized videos, and they contain very useful practical information, just like our classes, and you can code along with the tutorial videos. They are like demos, okay, very short demos. All right, so this is all we have with sets. With this we are done with sets as well. I hope you are able to appreciate why we need sets. They provide all these set operations which are very useful in certain contexts, and they have elements that are unique, and therefore we can use the set elements as the keys in a dictionary, and you can do all the standard operations on sets as well. Okay, because they are mutable. Okay, so you can add to a set and remove elements and do all that, but you cannot index a set, isn't it? Okay, because it is unordered. Okay, so that's all we have. Okay, now what I'm going to do is I'm going to post take some questions, and then I'm going to post some tutorial videos, okay, on functions, more tutorial videos on functions and conditional execution. I have some theory for you on conditional executions. So I'm going to post it as a video. It will be just 5 minutes or something. So those of you who have any sort of clarification or further understanding on these topics will find the video very, very useful. I'll also be posting the slides that are relevant to these theory, okay, and I think you will really find it useful, especially if you've not had a background in programming. You'll find these videos very, very useful. Okay, so that's all I have with sets. So any questions you please raise, and we'll also go to our Q&A session and see any questions that are posted there. Okay, so any of you, any question? Okay, so we have the Q&A open. I just it had to be open now, so I just opened that. So okay, so Vijay, can you just post your question in the Q&A?
Okay, sir.
Yeah, and let's have the other question. Bhavna, can you also please post your question in the Q&A? So let's have it. Let's move them all to the Q&A. So any question with the sets as well, please post it in the Q&A. So let's have some interaction in the Q&A. So let's all go to the Q&A. So I hope I'll just keep this open for a minute or so while people post their questions. Please go over this. Okay, so let's go to the Q&A, everyone. Okay, so we have a lot of questions. All right. So first question. So all of you post in the Q&A. So we have a question. So people can vote on the questions as well, so that I know whether a lot of you are having the same doubts, isn't it? Then I can find out, that these are areas where I can also clarify more and stuff like that. So feel free to vote on the questions as well. Okay, so Harini has asked a question. So will sets be used for large data sets? If so, then how we perform indexing? Since indexing is not available, how will we do that? Okay, what is the alternative? All right, it's a good question. You can use sets for whatever data set we like. If it's a large data set, big data, whatever it is. If the set is the right, if we want to do some operations on the data set that require a set data type, then we have to use a set data type. For example, if you want to find the intersection between two big data fields, isn't it? You have two big columns, each having, let's say, 10,000 entries or more, and you want to find the overlap between the two columns, then we have to use a set, because you can say each column is set 1 and set 2, and then you just say set 1 and set 2, and then you'll find the overlap between them. So, which data set we use, isn't it? That's a very key decision that we make in data science. Okay, that is, let's say that all of us are now here in this course because we would like to analyze data, isn't it? So whether you are in robotics or manufacturing or biology, isn't it, or computer science and data science, we have some data set, and this data set may be generated by the experiments in our field, isn't it? I do some automation, some mechatronics, whatever it is, and I have sensors, I generate a lot of data, then I want to analyze the data, isn't it? Finally we have a data set, and we want to analyze the data set, and the data set may be a high throughput data set, and we want to analyze this high throughput data set. So therefore it is big data. Okay, so let's just call it big data from here on, okay, for the rest of the course. And in this big data, okay, and we want to analyze the big data, and let's say that you want to find some overlap between two columns, two fields in the big data, then you can do it easily using a set data type. Okay, so which data type you use for representing the big data is a very key decision that we make, and this decision will enable us, isn't it? Is key, because that forms the foundation for the downstream processing and analysis that we do. Once you have represented some data type, you are going to work with that data type, and you are going to model that data type, and you are going to analyze the data type. So the data type must be amenable to all this analysis, isn't it? Okay, so if you choose a wrong data type, then it may not be able to do the all the required analysis on the data data set. Okay, so choosing the appropriate data type is a key decision that we make. Okay, so that the downstream analysis is possible. Otherwise, the analysis may not be later we may not be able to analyze the data set. Okay, so it's a key decision. Okay, that we have to consciously make. So, given the problem at hand, you make a decision. Okay, so this data set. Okay, first I want to determine some overlap between the columns. So therefore, I have to use a set. There's no other way about it, isn't it? That's the best optimal data type to use for that problem. And then later on, you can represent it as a tuple, because you don't want to modify the values and all that. And then you want to do some processing. Then you want to do some further analysis. You want to do some statistics. You want to do some machine learning. All that you can do. Okay, so you can give some different data type at that point. Okay, so set has a value. Okay, so it depends on the problem at hand. Okay, now Suppose you want to use the set itself for analysis and all that, then it may not be possible because the set is not ordered. Okay, so every time you pop an element from the set, some random element will be popped. It won't be the first element in the set. Whereas if you use the pop method with a list, it will always be the first element in the list. Okay, without any argument to the pop, it will pop the first element. Alright, so that doesn't happen with the set. Okay, because the set is unordered and every time you access the set, the elements may be in a different order. Okay, so the set is not used for ordering ordered purposes. So you cannot use it where you require to index the data, the elements in the data set. If you require to index for the problem, then the set cannot be used. So that is the answer. Okay, wherever indexing is required, you may not be able to use the set. But for example, you want to make you want to determine the keys for a dictionary. Okay, so then you can use a set and ensure that the keys are unique, and then use that as the keys for your dictionary. That's another application of set. Okay, one is for performing the set operations, another for getting the keys of a dictionary. Like that, there are many applications of a set. Okay, so when you want to do these applications, we use a set. When you want to index, don't use a set. Okay, because it's not possible with a set. We have the other data types for that. Okay, so I hope that has been clear to everyone. Alright, so the next question we have is, we'll be using add for ordered data types while we use append for the ordered ones. Okay, so what is the logic of the language I was talking? Okay, alright, now what I was saying is, for some data types we are using append, some we are using add. So how do we remember these different methods, isn't it? Easily we can remember by putting it in the Python idle, and you can type it and see which one works. Okay, and whatever is working, you can use it. But if you are programming and you have to switch between the console and the program, it becomes tedious. After a while, you are supposed to be a conversant in the programming and know all these, isn't it? So what I'm saying is, there's an easy way to remember whether we use append for a data type or add for a data type. If the data type is mutable, okay, and if it then you can use add or append to it, isn't it? But whether it is append or add depends on whether the data type is ordered or not. If the data type is ordered, then there is a last element, so we can append to it. Okay, append means we add to the end. When you are adding to the end, it becomes append. Okay, so if to add to the end, there must be an end to the data type. That means it must be ordered. Only if it's ordered, it has an end. You're able to follow that. So therefore, then we can use append. So like a list has an end. List is ordered, isn't it? So we can use append with list. Whereas the set is not ordered, so you can only add to a set. Okay. So similarly, we use update to add multiple elements. Okay. When you say extend for a list, you are extending the list. That is beyond the last element. That is for an ordered data type. Okay. But when you want to add multiple elements to an unordered data type, like a set or a dictionary, the method we use is update. And you say update and you give them multiple elements to be added. Okay. So I hope that was clear. Alright, so Vijay has a question. Now, what is the difference between print hello, comma, name and print hello, percentage name? Alright. Oh, that's a good question. Alright, so there's no difference. Okay. So you're just interpolating the string. There's actually a difference. Okay, let me tell you the difference. So here, Vijay, when you're saying percentage yes, okay, this name has to be a string variable. Okay, this name has to be a string variable and its contents will be interpolated. Alright, so now when you say, alright, name here, again this name has to be a string variable. Okay, now because here you have opened the print with a string, but suppose you just said print of x and x is an integer, print will print the x as a integer. Now suppose you say hello and comma x and x happens to be an integer, then this will throw an error because you are trying to combine a string with a int. Okay, so therefore to print a int in a string along with a string, you have to say str of int. Okay, so you have to say str of x and that will print the x. If you just print x, that will work, but if you say print of hello comma x, that may not work if x is a int. You have to say print of hello comma str of x, then that will work. Okay, but here it is straightforward that it's a string interpolation. Here it is implicit. Here the string interpolation is implicit. Okay, so I think the difference is between implicit and explicit interpolation. Here there is no interpolation, it is just added. Here it is interpolation. So these are some minor points, but otherwise they have the same effect. Okay, there is not a difference in the two, they have the same effect. Okay, so that is all I have to say about that. Okay, so that's a very minor fine point of the language. Now Sankaran has I think it's an observation that he is making or a comment upon using len of key name of key value. It's not key name, it is the dictionary name. Okay, it's not the key name, it's the name of the dictionary. So len of dictionary name of key value, to get the number of values the key has. The key usually has only one value, but the value may be made up of number of elements. Okay, to find out the number of elements in the value, we say len of dictionary name of some key. Okay, that will give you the dictionary name of key will give you the value map, and that value may have multiple elements. To find out the number of elements, you say len of that particular value, isn't it? Okay, but if the value happens to be a string, then the len of a string will only give you the number of characters. Okay, so that is the way the len works. Okay, if you have a data type, when you say len of a data type, the len will function according to the data type. You have a string, you say len of string, it gives you the number of characters. This we have already seen with strings. So if the value is a string, it gives you the number of strings. If the value is a list, it gives you the number of elements in the list. If the value is a set, it gives you the number of elements in the set. The value is another dictionary. It can be a dictionary, okay? The value can be a dictionary, but the key cannot be a dictionary. We have some constraints on the key, isn't it? The key has to be a number or a string or a tuple, but the value can be a dictionary. And when you say len of the dictionary, it gives you the number of items in the dictionary. All right. So whatever you're saying is correct, and that follows from how len works on the different data types. Okay. So I hope that is also clear. All right. So I think there are no more comments or questions. All right. So I hope this has been clear to everyone. All right. So what I will do now is I'll post some tutorial videos for everyone. Okay, so you have some more time. Do go over the tutorial videos. I'll post it right away. Okay. So are there any more questions in the class? Okay, so there don't seem to be any more questions. All right, so we'll close this. What I will do is I'm going to stop the session, okay, and I'm going to post some material, some tutorial videos as well. So go over the tutorial videos. I'll also be posting the script for our session today, okay.